In today's lesson, we look at some important definitions of what does it mean for two lines to be parallel and what does it mean for two lines to be perpendicular. Have you heard those words before? Parallel and perpendicular. Okay? Parallel means going right beside something else. And so in lines, when two lines are parallel, like this one and this one, they have the same slope. For perpendicular, perpendicular is when the lines meet at 90 degrees. So parallel lines will have the same slope. So these lines, y equals 3x plus 5 and y equals 3x minus 3, well, you could use your slope-intercept way of finding the graphs for these. So we have 3x plus 5. We know that it will have a y-intercept of 5. And if the slope is 3, we go up 3 over 1. And there's the line. I'll put a green box around that one. And if I graph the other one in blue, it has a y-intercept of negative 3, but it also has a slope of 3. And when we draw both of those lines, we can see that they're parallel. So an easy way to tell if two lines are parallel is to look at their slopes. And if their slopes are the same, you'll know the lines are parallel. If two lines have slopes that are negative reciprocals, they are perpendicular. What does a negative reciprocal mean? An example right above would be if I took one fraction that was 2 over 7, a reciprocal means you flip the fraction. You've seen that because you've learned about dividing by fractions, and you've learned that phrase, to divide by fractions, we need to multiply by the reciprocal. So a reciprocal is when the fraction is flipped. And if they're negative reciprocals, that means one of the fractions is positive and one of them is negative. And it doesn't matter which one is which. So the example I have here is the first one's positive and the second one's negative. If that happens, you will always have two lines that are perpendicular. And we're going to see with the graph why that happens. So here's our example. Can you see in this first one our slope is 2/3? And in our second one, our slope is negative 3 over 2. So it was very handy that both of those equations were in slope-intercept form. If I graph the first one, again, I'll do this one in blue. It has a y-intercept of 1. So this technique of using y equals mx plus b to graph is very helpful because you've got a point where you can start with, and then you can use your slope. The slope is 2/3, which means a rise of 2 and a run of 3. I can start from this point, go up 2 over 3, up 2 over 3, up 2 over 3, down 2, back 3, down 2, back 3, down 2, back 3. And I can get the blue line that way. Wow. There we go. If I do the second one in green, it has a slope of negative 3 over 2 and a y-intercept of negative 2. And this one, my slope says go down 3 over 2, down 3 over 2, over 2, up 3, over 2, up 3. it will always happen that if you have negative reciprocals, you will have two lines that are perpendicular. If you look at it from a specific point, so I'm just going to take a random point here. For 1, I'm going to do a slope of 2/3, which means up 2 over 3. And for the other one, I'm going to go down 3 over 2. You will always get a 90-degree angle when you do that. So if the slopes are negative reciprocals, the lines are perpendicular. So with this information, they just open up a number of questions that you can do with these. Can you find the slope of a line parallel to that one? So what do we know about the slope of this line? It's equal to 4. What would a parallel line have a slope of? Also 4. If we look at our second one has a slope of -5. A perpendicular line would have a slope of, now sometimes what you might want to do, if you just have a slope that's an integer, like this case, you can always write it as a fraction. I could write -5 as -5 over 1. So if I wanted to do the negative reciprocal, well, the reciprocal would be 1 over 5. Since this one's negative, the negative reciprocal would become positive. So the slope of a perpendicular line would have a slope of 1/5. Find the equation of a line that is, and those two dashes are supposed to be short for parallel, parallel to y equals 3/5 x plus 2 and passing through -1, 3. So we have to break this question down. What are we trying to find? An equation of a line. So first of all, we start by reading find equation of a line. That should trigger something from what we've been doing so far. What do you need to find an equation of a line? We need a slope and a point. So we need slope and we need a point. Okay? So as soon as you see find the equation of a line, that comes to your head. These are the main things that I need. I might have a shortcut because we've had the shortcut where we know the slope and the y-intercept that we could do it right away. But we keep this in perspective. I need, in order to find an equation of a line, a slope and a point. Does this question give this to me, or do I have to do some more work? That is parallel to y equals 3/5 x plus 2. What does that tell us? It has the same slope. So do you know the slope of that line? Yes. In this case, that was already in y equals mx plus b form, so we know that our slope is also 3/5. Sometimes they'll give you parallel to an equation in general form, and you have to manipulate it or change it to y equals mx plus b. But this part where it tells us it's parallel, that's giving us a hint for the slope. And in our case, the slope was really easy to see. It's just 3/5. Do we have a point? Yes. It tells us it passes through -1, 3. Okay? So as not to be redundant and over again, now I'm going to flip-flop between methods. So I'll do this one with method 1, and next time I'll do method 2. And I'll flip-flop. So if we did method 1, which was y equals mx plus b, we plug in our slope, and I'm no longer going to write those extra things because you have them in your notes already. 3/5 x plus b. And then we plug in our point. Y is 3. X is 1. And now we have to get b by itself. So we would get 3 equals negative 3/5 plus b. If I wanted to get b by itself, if I wanted to get b by itself, I would have to add 3/5 to both sides. How do you add fractions? You need a common denominator, so 3 is 15 over 5 plus 3 over 5. And so I get b is equal to 18 over 5. So my equation of my line, I can now write it out, is y equals, my slope was 3/5, and my b value was 18 over 5. And we would be done unless we read the question and it says write it in general form. Oh. Write it in general form. What do you know about general form? You can have some negatives, but just not in front of the x. But before we get to the positive and negatives, we have to have exactly what you said next. No fractions, no decimals. Do we have fractions? Yes. What could we multiply to get rid of one of the fractions? 5. Would it get rid of the other one too? Yes. It's kind of nice. So if you multiplied everything by 5, well, this 5 would simplify with this 5, and this 5 would simplify with this 5, and we just get 5y equals 3x plus 18. And now we make one side equal to 0. And I guess changing to general form wasn't that bad. So again, to recap, find an equation of a line. That's triggering you to say, I need these two things for an equation of a line. I need my slope, I need my point. Okay? And then use the information to work until you get those two things. Then we can use either method 1 or method 2. So our next example. Oh, find an equation of a line. I need my slope, and I need a point. This time it's perpendicular. That's the symbol for perpendicular, because that is a 90-degree angle. On your test, it will actually say parallel and perpendicular, and on your exam, it will actually say parallel and perpendicular. So perpendicular to y equals 4x plus 3, and passing through 3 comma negative 5. So if we need a point and a slope, do we have a point? Yes. Passes through 3 comma negative 5. Perfect. How are we going to find the slope? It's going to be the negative reciprocal of this one. This one's in y equals mx plus b form, so we know the slope of this line is equal to 4. That means the slope of our line is going to be negative 1 over 4. I should have used the second method for the first one and the first method for the second one, because this one asks for the slope-intercept form, but it really isn't going to take any significant amount longer. So how do we do point-slope form? We plug in our slope, negative 1 over 4, plug in our point, y plus 5, because it'd be y minus a negative 5, x minus 3, distribute the negative 1/4, negative 1/4 x plus 3 over 4. Remember, how do we multiply fractions? We multiply our numerators and we multiply our denominators. So when you're multiplying by -3, you might change it to -3 over 1 as a fraction so you can see your fraction rules better. Finally, I need to subtract 5 on both sides. Are you okay when I write subtract 5 on this side that I write 20 over 4? Why am I doing that? Because I need to have a common denominator when I'm subtracting my fractions. So my final answer is -1/4 x minus 17 over 4. Put a circle around that. All right, I'm going to get you to do the next one on your own. I'll put the answer up in a bit so you can check, or you can call me over when you're done. If you got this one and you want to keep working ahead, that is fine. So we need our slope. In this case, since it's perpendicular, it will be 3 over 2. We need a point, and we were given a point 1, -3. So if I use, what method did I use last? Last I used method 2. I'll use method 1. If you use y equals mx plus b to find your equation, we know that our slope is 3 over 2. We can plug in our point, -3 for y, 1 for x. And if I want to solve for b, I need to subtract 3 over 2 on both sides. And this is where we walking around, this is where the majority of the mistakes are made. Adding and subtracting fractions and dealing with negatives. Yes, you'd learned that first in grade 7 and grade 6 and grade 8, but it is the thing where it's so easy to make mistakes with. So take your time. If you want, okay, I'm going to change to a common denominator. When I change -3 to a common denominator, the negative doesn't go away. It's still -6 over 2. And if I'm subtracting 3 over 2 from that, now I've got a common denominator. How do I subtract? -6 minus 3, -9 over 2. Now that you've got that, you can write y equals mx plus b. This one asked for general form, so we're going to multiply everything by 2 to get rid of fractions. 2y equals, 2's here will cancel, the 2's here will cancel. 3x minus 9, 0 equals 3x minus 2y minus 9. So again, the ideas aren't bad, but we start to get with fractions and negatives, and it's so easy to make mistakes as we go through. So we have to be careful with that. But as long as you've got the big idea, I need my point and I need my slope, and I know I can plug it into either method 1 or method 2, you're going to be fine. So I'm going to quickly do this next one together. Okay, again, it says find an equation of a line, so just to be consistent, these are the two things I need. I need a slope and a point. It's perpendicular to 2x minus 3y plus 5 equals 0 and has an x-intercept of -6. So in this one, nothing comes as clearly as the previous one. They gave us an x-intercept, but they didn't say a specific point. But an x-intercept is a specific point. We know that the x-coordinate is -6 and the y-coordinate would be 0. They give me that it's perpendicular to that line, so that should help me with the slope, but that line doesn't tell me the slope when it's in that form. It's in general form. So I'm going to change 2x minus 3y plus 5 equals 0 into y equals mx plus b, because then I'll be able to find my slope. If I do that, what do I get? Well, I would have 2x plus 5 equals 3y. If I move the 3y over to the right-hand side. I did that so that I have more positive values. And then I can divide everything by 3. That would get y by itself. 2/3 x plus 5/3. If it really bothers you that y is on the right-hand side, you can rewrite it. Y equals 2/3 x plus 5/3. So our slope of that line is 2/3. We want to find the equation that is perpendicular. So what's our slope going to be? -3/2. Once you've completed the box of what you need, now you can go and use either method 1 or method 2. I think we're on method 2's turn. So point slope form, y minus y1 equals m x minus x1. So I get y equals 3/2 x plus 6. If I distribute, again, you can think of 6 as 6/1. 3/2 times 6/1 will be 18/2. 18 divided by 2 is 9. And that is in slope-intercept form. So again, a little bit more work this time because we had to do some work to find our slope and then make it perpendicular. The y-intercept, the x-intercept gave us a point. So I would like you to try this one. What do we need? We need a slope and our point. And parallel to 3x minus 5y plus 7 equals 0. So I'm going to change this into y equals mx plus b. Divide everything by 5. To find out my slope is also going to be 3/5. It has to have the same y-intercept as -2x plus 7y equals 14. Get yourselves ready. How do you find a y-intercept?
Make x equal to 0. Make x equal to 0.
Make x equal to 0. I would say that your readiness was mediocre. Insufficiently mediocre. So we find a y-intercept by making x equal to 0. So if you did that, you just get 7y equals 14 divided by 7, and y is equal to 2. So your point is 0, 2. Can you see that you could do the shortcut here? We have the slope and our point happens to be the y-intercept, so you could just write y equals mx plus b right away. But if you went through the process of plugging in the point, that'll work out exactly the same, which you probably noticed. So our last example, find the equation of a line perpendicular. So we're finding the equation of a line. Again, what do we need? Just like every single time, to find an equation of a line, these are the two things you need, a point and a slope. We don't have the slope, but we know that it's parallel to 3x minus 5y plus 7 equals 0. So you might notice, hey, this is the same equation from before. So you wouldn't have to spend all that time rearranging it. But if you didn't know that and you rearranged it, you should have still got the same equation as before. The slope of that line is 3/5. So the slope of our line, now that it's perpendicular, will be the negative reciprocal. And it passes through the x-intercepts. Prepare yourself. How do you find an x-intercept of an equation?
Make y equals 0.
Good. So if I make y equals 0, I'm going to get 3x minus 18. Add 18 to both sides. Divide both sides by 3. And I have an x-intercept. So if I use method 2, I don't know which method I'm on right now. If I use method 2, I can plug in my point y minus 0 equals m negative 5/3 x minus 6. I can distribute the negative 5/3. Negative 5/3 x. This will be positive 30 over 3, which will be positive 10. It asks for general form, which means no fractions. Multiply everything by 3. And then move everything to one side. Five x plus 3y minus 30 equals 0. So for many people, they feel that these questions are the hardest questions of grade 10, okay? Because there's a lot of things you have to do. In fact, we could say this question has 1, 2, 3, 4 questions combined in one question. Why is that? Well, one type of question is finding an equation of a line. Another type of question is rearranging an equation from general form to slope-intercept form. Another type of question is finding the slope once you have it in slope-intercept form. Another kind of question was finding an x-intercept. And we're combining all of these things together in one question. So because we're combining 4 mini questions together into one question, that can make it a lot harder. Because if you forget how to do one of the mini questions, you can't do the whole question. But if you take your time, keep everything separate, each of those mini questions isn't that bad. They do take practice, so make sure you're practicing these because you're practicing a lot of things while you do them. But they're helping you all the way through. So for that reason, some people find these really difficult because there's a lot of things involved. But with practice, you're going to get better at each of those individual things and then be able to do these big questions as well. So we've got practice sheet number 9. It's a really good one to do. And then I've also handed out your pre-test to get ready for your quiz on Tuesday and test next week on Thursday.